Okay, welcome to this next video, guys. We're going to be talking today about scale drawings, which is a pretty important one. It's got a lot of real life sort of uh, usefulness, because you're going to see scale drawings and have to interpret them a lot throughout your life. Okay, so for this one here, you're going to want to be able to, so students can solve everyday problems involving rates, ratios, and percentages, and you'll be able to, at the end of this, calculate the actual distance from a scale drawing and create a scale distance that's going to represent some real actual length. Okay, right. Maps, maps, maps. So we need to worry now about maps and why do scale drawings exist? What's kind of the point of them? Well, firstly, the point's going to be is the idea that if, let's say that we had a map of Australia, and you're like, well, let's just draw it exactly the same size as Australia. Well, you're going to have this gigantic map, sort of like this, and here's you trying to roll it up, and carry it around. You need like some kind of truck to be able to take your giant map of Australia around, just to sort of whip it out at parties, maybe to say, hey guys, look at my life-size map of Australia. It's sort of useless, and so that's where we come with this idea of scales, to be able to bring things down, but still be able to understand the actual distances and actual lengths we're kind of talking about. Okay, some key ideas for us to sort of think about. Right, first, scale drawings are exactly the same shape as their object, and they clearly display the scale ratio on them, okay? Which is pretty important for us to sort of note. And here's another very important thing to worry about, is that the scale order is very important, okay? So our scale order is that the drawing length needs to be to scale to the actual length. Okay, so this 10 is to 100. If you saw that on a scale, you know that means that could be like 10 centimeters in real life. In reality is, whoops, sorry, not 10 centimeters in reality. Dear me. 10 centimeters on maybe the map is going to be 1,000 centimeters in real life. So in reality, okay, and so that's an important thing for us to realize. Now, same with this one here. So this one would be sort of a if the map was sort of smaller than the real thing, whereas this one here, 50 to 1, that was if the drawing was sort of a magnified version of the thing that was in real life. And so this would be that sort of like 50 centimeters on the drawing would be 1 centimeter in reality. So you might want that if you're doing sort of an exploded view of a small thing like a microcircuit, or maybe the internals of a bug or something, maybe a bacterium, that kind of thing. Okay, let's have a look at some examples now. So let's say pretend you have some construction plans that show a scale of 1 is to 100, and you measure some room to be 3.5 centimeters by 4 centimeters. What is the actual area of the room going to be? Okay, so if we sort of pretend that here's our room and it's 3.5 centimeters we measure, and this measures to be 4 centimeters, what is our actual area going to be? So the first thing we're going to do is let's convert the scale, the distance, okay? Alright, so if we have 1 is to 100, alright, that means that for every 1 centimeter, we have 100 centimeters. So that means that our 3.5 centimeters is going to be 350 centimeters in real life, because we've multiplied by 100. And again, our 4 centimeters is going to move up to becoming 400 centimeters. Okay, now again, centimeters is not like the easiest thing to work with, so let's think about those in terms of meters. Okay, so our new one is that 350 centimeters is the same as 3.5 meters, and if we have 400 centimeters, that's the same thing as 4 meters. Okay, right, done, almost. So now our last thing is going to be is we're going to be now find the area Okay, so the area of that rectangle is equal to length times width, which is 3.5 times 4, which is 14 square meters. Okay, so that's how we're going to sort of go about that one there. It might seem a little bit confusing for you, but the idea with these rates and ratios, similar to fractions maybe, is that it's about the idea of starting to be able to think in that sort of mode of thinking, so that these kind of problems become very easy for you. Okay, another problem here for us. So let's say you busted out Google Maps and you measured the distance across the Fred Stoltz Oval here, and you've measured it to be about 160 meters, as you can see in just here on the drawing. You can see that it's about 160 meters, and if you want this to be 4 centimeters on a drawing, what is our scale factor going to be? This is actually an interesting question. How would we create a scale factor that's going to make a drawing that wouldn't be too unwieldy? We want that diagonal length of the oval that we're going to draw to be only 4 centimeters. Okay, so let's say to ourselves, right, we want 4 centimeters to be 160 meters. Okay, now we can't just leave it like that. I mean, if it was that would just be super easy. But remember that idea with ratios is they have to be the same set of units, and here they are not, because we've got centimeters and meters. Okay, so the first thing we're going to do is let's convert 160 meters to centimeters. Right, so 160 meters, we're going to have to multiply by 100 is equal to 16,000 centimeters. Okay, makes sense. 160 times 100, 160,000 centimeters. Okay. Sorry, 16,000 centimeters. Right, so that means that we got 4 centimeters is to 16,000. All right, now I've sort of chosen this a little bit kind of easy because 16 and 4, and you'll see why in a minute. We need to try and get this down to our scale factor. So when we have a scale factor, this first part is always going to be 1. Okay, now how do we get 4 to become 1? We're going to divide by 4. So that means to this I've also got to divide by 4. Okay, and so now we've got 1 is to 16,000, so that's going to be 1 is to 4,000, because 16,000 divided by 4 is 4,000. Okay, and so that's how I go about creating a scale factor from a drawing we've already got down to a sort of a scale that's going to be manageable for us to actually do a drawing of something. Okay, so again, with these ratios and rates sort of problems as sections, as we'll see, the number one way to become confident with this is just bang, 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 have a lot of goes at a lot of different stuff, and try as many exercises and stuff as it takes to become confident with this sort of stuff. Okay, thank you so much for watching.